Hello everybody. Today we're going to talk about f of x and function notation. So function notation is basically a different way of expressing inputs and outputs. So for example, if I give you the equation y equals 3x minus 7 and I ask you to graph this, well, what we did in class is we made a table. Okay, so we picked numbers for x. So usually we did 1, negative, 0, and then 1 or 2 positives. And we plugged them in. I'll just put 2 down here so you can see. And we plugged them into 3x minus 7. So for example, if we plug in negative 1, we have 3 times negative 1 minus 7. First, we do the multiplication, following order of operations. For any time we plug something in for x, we're doing order of operations. So 3 times negative 1 is negative 3. Negative 3 minus 7 is negative 10. So when we plugged in the input of negative 1 for x, we got a y value out of negative 10. Okay, so remember, because we picked values for x and we got out y values, x is what's called the independent variable because we plug in values for x. And y is a dependent variable because the value of y depends on the value of x. So when you have an equation of two variables with x and y, the values of x and y change based on each other. Okay, but we do plug in or pick values for x to get our y value. So again, x is independent because we're picking values for it. Y is dependent because the value of y depends on the value of x. Okay, so what happens in function notation is that the y gets replaced with f of x. And let me show you what I mean. So here's exactly what I mean. Let's say we have the equation y equals 4x minus 8. Well, remember, x is our input, okay? Y is our output. But what happens with function notation is the y gets replaced with what's called f of x. And I'm doing my best to write this the right way, but when you see it in sources and textbooks, this f of x is italicized. So that's how you know it's function notation and not just like f times x. So the y gets replaced with f of x. And then we have the same second part of the equation, 4x minus 8. What function notation is doing is it's showing what the input is. So for example, let's say we evaluate this function for x is 3. Well, instead of saying y equals and then 4 times 3 minus 8, we say f of 3, and then that equals 4 times 3 minus 8. So now when we do our math on this, we're only doing the math on the right-hand side. We're never touching the f of part because that states our input. So 4 times 3 is 12, and then 12 minus 8 is 4. So finally, for our final answer, excuse my writing here, I'm trying to smudge it on the space here, we would say f of 3, that's our input, equals positive 4. So what that is saying is that when we plugged in an x value of 3, we got an answer of of positive 4. So we could write this as an ordered pair if we wanted to. The answer would be 3, 4 if we wrote it as an ordered pair. So that's function notation. Function notation, it states what the input is and then what our answer is. Okay, it's just another way of expressing inputs and outputs. There we go. So let's say we have f of negative 3. All that means that we're taking negative 3 and plugging in for x. So we write f of negative 3, and we're evaluating functions using function notation. This part, the f of, will always remain the same because it tells us what our input was. All our work happens on the right-hand side here. So now we do the math once we plugged in negative 3 for x, and we get negative 9 when we multiply these, and then negative 9 minus 7 is negative 16. So f of negative 3 equals negative 16. That's our final answer written in function notation. Now, if we weren't doing function notation and we were just doing x and y, then the y value would be negative 16, and it still is. But again, what it's saying here is we plugged in an x value of -3, and what we got out was -16. So if we wanted to write this as an ordered pair, it would be -3 comma -16. So hopefully you're seeing the relationships between just having x and y, two variables in an equation and function notation. All that happens is the y is replaced with f of x, but that f of x part just tells you what you're plugging in for x. But when you get your answer, that still is your y value or your output, depending upon the variables you have. So let's look at another. Let's say we have f of x equals -3 x squared plus 4. And let's say we're going to evaluate this, or they want us to evaluate this for f of, we'll do, let's say, -2. Okay? So the first thing we do is plug it in for x. Now for these larger problems, I recommend writing out the whole thing. So we do -3 and in parentheses, because there's multiplication and exponents going on here, we write -2. Sorry, my pen's not for a second. -3 times parentheses -2 squared plus 4. Now, again, for some reason when we get to function notation, a lot of people seem to forget their order of operations, but all you're doing is order of operations. So the first thing we do is square -2. -2 times -2 is +4. And by the way, anytime you square a number besides 0, it's always +4. Or, excuse me, let me rephrase that. Anytime you square any number, it's always a positive answer, except for when you square 0, which is just 0. So anytime you square a number besides 0, that answer is always positive, because when you square any negative number, a negative number times a negative number is positive. Now we'll do a multiplication. We get -12, and then -12 plus 4 is -8. So on the side here, I'll write f of -2 equals -8. So by writing it in function notation, it's telling us we plugged in -2 and we got an answer of -8. Again, if we wanted to write that as an ordered pair, it'd be -2 comma -8. So the y value is in fact -8. But again, this is function notation. Here's another one. So f of x equals x squared minus 2. Let's say we want to evaluate that for f of a. Okay, that gets a little tricky. Well, all that happens here is the thing that's next to the f of part that's in parentheses, that is your input. So all you do is you take the input, in this case a, and substitute that in for x. If you see the difference here, the only thing that changed is a went in for x. So I do a squared. Give me 1 second. So we do a squared minus 2. And because we don't know what a is, we can't do much more with that. So actually, that's our final answer. So we say f of a equals a squared minus 2. And then these aren't like terms, so we can't combine them or do any more math to it. So that's our final answer. So the key here that I wanted to show you was that whatever's next inside parentheses next to the f of part, that is your input. That literally goes in for x, or the input value, the input variable. So function notation doesn't have to be f of, it could also be g of, and here's an example of that. So actually I give you two equations in function notation. So we have f of x equals -x plus 4, and then we have g of x equals x divided by x plus 8. So when you're evaluating functions using function notation, you have to match up the letters properly. So for example, if I'm asked of g of 10, like the second one here, we plug it into this above equation in function notation. So I would do 10 over 10 plus 18, or plus 8, excuse me, I said the answer there. And then 10 plus 8 is 18, but then we still have to simplify that. So 10 over 18 is going to reduce to what? Ask yourself that right now. So 10 over 18 is going to reduce to 5 over 9. So that is your final answer. So g of 10 equals 5 over 9. Going back over here, it says f of -2, so that means we plug it into the f of x. equation. So go ahead and see if you can do that one on your own really quick. So if you need to pause the video, I'll pause for about 10 seconds to let you try this. Okay, so when you plugged f of, or negative 2 in for x, excuse me, you should have got an answer of positive 6 because the negative in front of x has to stay there when you plug it in because x is being multiplied by negative 1. So that becomes a positive 2. 2 plus 4 is 6. So f of negative 2. So it's telling us we put an input of negative 2. We got an output of positive 6. That's our final answer. And again, the y value would be negative 6. So hopefully you have a better understanding of function notation. Couple key things. Remember, the f of x is basically the same thing as y. But what's nice about function notation is that it tells you what your input was along with your answer. Remember, all your work happens for function notation on the right-hand side of your problems. And make sure you just use order of operations. So you're looking for parentheses, exponents, multiplication and division, any of it from left to right, and then addition and subtraction from left to right. So just do order of operations and then simplify or get your final answer. And then say f of whatever your input was equals your answer. That's it. So if you have any questions, please let me know. Thank you very much and have a fantastic day.